ihasmath, and you're going to learn how to describe features and transformations of parabolas. If you have been following the other videos in the playlist, you should be able to identify some of the key features of a parabola already. Instead of identifying the equation of this parabola, I want to focus on its key features. Keep in mind that you won't always be able to identify all of them, but in this case we can. The key features are the x-intercepts at 5, 0 and -1, 0, the y-intercept at 0, -5, the axis of symmetry at x is equal to 2, and on the axis of symmetry the vertex at 2, -9. When a question asks you about the key features of a parabola, this is what it is about. If you want to compare the relationship of two given parabolas, in other words, you want to describe how one parabola can be transformed into a second one, this is how you do it. There are three basic cases to consider: a translation, a reflection, and a vertical stretch. In the example on the left, the red graph is the result of a translation of the black graph 4 units to the left and 4 units up. In the example in the middle, the red graph is a reflection of the black graph on the line y is equal to -1. Finally, in the example on the right, the red graph is the result of a vertical stretch of the black graph by factor 3. It's also possible to find the equation of a translated parabola. There are two different ways of doing this, using the graph or using the equation. Let's assume we've just translated the black parabola 1 unit to the left and 4 units up. We can now simply write down the equation of the red parabola in vertex form. However, it's also possible to do this without the graphs. The equation of the black parabola in vertex form is y is equal to x minus 2 in brackets squared minus 9. The number in the equation tells us that the vertex has been shifted 2 units to the right and 9 units down compared to the basic parabola y is equal to x squared. In order to shift this parabola 1 unit to the left, I need to change the x in the equation to x plus 1, and in order to shift it 4 units up, I need to add another 4 at the end. Although this is a correct equation of the red parabola, we should really tidy this up a little, and we get the same equation as before. The same method can be applied to the factorized form of the black parabola. X plus 1 for x, to shift it 1 unit to the left and add plus 4 at the end. Although I can tidy this up a little bit, it doesn't result in a factorized form, and you can see this in the graph. The x-intercepts are not easy to read off. If you use the calculator to find the equation of the black parabola, you can still do this, but it gets seriously messy. The idea is the same. Substitute x plus 1 in for x and add 4 at the end. What a mess. If you've got the algebra skills, you can tidy this up, but I think you can see why I like the vertex form best. Let's do 2 more examples. Try them yourself first. You can either draw the parabolas first or use the equation straight away. Pause the video and give it a go. I want to shift the first parabola 1 unit up and 3 to the right. 3 to the right means substitute x minus 3 in for x, and 1 up means add 1 at the end. Don't forget the brackets here. In order to shift the second parabola 3 units to the left and 5 units down, I do the same thing. 3 to the left means substituting x plus 3 for x, and 5 down means -5 at the end. Simplifying this is easier. Finally, I could have come up with an answer by drawing the parabolas first, shifting the vertex as required, and then reading off the equations of the resulting parabola. Whether you want to find the translated parabolas by drawing graphs or substituting into the equation is often up to you. Sometimes, however, you will already have either the graph or the equation, and then one of the methods is quicker than the other one. With a little practice, you should now be able to identify key features of a parabola, describe the transformation of one parabola to another, and find the equation of a translated parabola.